I was working on some code when something really weird happened. I needed a generic way to fire commands, and when I inspected the result, my IDE suddenly started predicting exactly what type I was using. But how did it know? I didn't tell it anything, and yet the type checker seemed smarter than me. And that's when I realized that is the magic of generics. Here is the code example I'm working on. There is an execute command function that is marked generic, and I'll show how that works in a minute. Notice that the function takes a command of type iCommand of type T. Here is the command interface of generic type T. And finally, two command classes that satisfy the command interface. And now comes the magic. I create getPartsNumber command and execute it with the execute function. What is the result? It is an integer. Now notice that the execute command function knows nothing about integers. Let me use the second command. And what is R2? It is a string. How can the result of the execute command function have a type? So how did the type checker know the type of R1 and R2? Well, to answer this question, let's start at the beginning. For this, I will use a built-in generic container in Python, the list. Two things matter here. First of all, int and string describe the types of the elements inside the list, not the list itself. This works because list is a generic type. Generic containers allow you to specify the types of the elements they hold. And second of all, type hints are not enforced by the Python interpreter. Let me show you. I add a name to the numbers list. Now the type checker complains, but I can still execute the code. Once I start doing stuff with the numbers, Python will give a runtime error. But this proves type hints are not enforced in any way by the Python interpreter. Now, even if type hints are not enforced by the interpreter, they are still a great help when dealing with generic lists. And there are many of them. Check the description for a PDF I put together. It's a complete overview of generic lists. This is an absolute must-have if you want to choose the right generic list for your project and stay clear of the notorious covariant pitfalls. Okay, so Python has excellent support for built-in containers. But what if you want to build your own generic container? Now let me start by building a class that functions as a container for a single value. You see, generic containers do not need to be a list of things. They can also contain just a single thing. I start by creating a class followed by square brackets t. Now this marks the class as generic and introduces t. T is a type variable. It does not represent a value, but a type. But the type is not assigned yet. I proceed with a class initializer. T is used as type for value. Notice T is still not assigned a type. I create a method to retrieve the value. T is used as return type. So, what is the type of T? Well, that will be determined by the usage of the class. I instantiate box. Now you tell me, what is the type of T result? Yep, it is int. Look again at the code. T is a type placeholder. All that the type checker knows at this point is that box is a generic class parameterized by a type variable t. Then the type checker infers type integer from literal for. Class box is instantiated and the type checker binds t to int. From now on, every occurrence of t will be substituted with int in this box instance. Finally, when getValue is called, the type checker knows the return type t, which was substituted with int. Now remember, the inference of type variable t happens entirely at static analysis time. At runtime, the Python interpreter does not care about t. So, what if a generic class has more than a single inner type? No problem. Let's create a tuple with two typed elements. Yes, I know I can already do that with existing type hints, but let me show you how you would build that yourself. Generic classes support comma-separated type variables, here t and u. I use them to annotate the class initializer. Now, as before, t and u will be substituted when instantiating the class. I create two getter functions that return t and u. And finally, instantiate a pair. And what are the types of value 1 and value 2? Yep, a string and a float, inferred from the pair instantiation. Now, the next question you might have is, if generics are ignored by the Python interpreter, should I use them? And that is a good question. Python is a dynamically typed language that does not need type annotations at all. But let's say that you are already using type annotations but want to stay away from generic classes. What would you have to do to support type checking? To support type hints for a box with an integer, I would have to create a new class and annotate value as int. For a string, I do the same. And you probably already see where this is leading. This is not really an option. So the power in generic classes is the prevention of similar classes where only the inner type is different. With generics, we only need a single class. Now, if you come from a statically typed language, you might have seen that the generic type information can also be used at runtime. And I'll tell more about that in a minute. First, I'd like to come back to the example from the beginning. Do you remember that the type checker inferred R1 to be an integer? But how is that possible? Notice that this concrete execute method does not have any parameters. So how could it infer type integer? The crux is in the execute command function. Functions can also be generic. Placeholder t is introduced and the function expects a command of type t. When C1 is passed, the type checker checks if it is compatible with the I command interface. It is and searches for the first place of t in the body and finds the result type. It unifies t with the result type of the concrete command, and from that moment, the execute command function substitutes t with int. And when I hover over R1, the IDE reports its type is int. Now, I've packed the whole process into the free ebook, so don't bother scrubbing back and forth through this video. Just hit the link in the description and grab your copy now. Now, if you come from a statically typed language, you might have seen generics before. And there it gets even better. In languages like C#, the generic information is also known at runtime, which allows you to do all kinds of generic magic. But I'll tell you a secret. In Python, the generic information is also retrievable at runtime, but it is still very experimental. But if you're feeling brave, click on this video and see why type hints are borderline magic.